Today we are going to talk about quadratic functions, and we will explore their graphs. Our last unit that we talked about at school, also the review that you guys did on Khan Academy, was about factoring quadratic equations. We factor quadratic equations, we solve them, so we were already working with quadratic equations. Now what we are going to do is we are going to explore the quadratic equations, and we are going to see what the graph of the quadratic function looks like, and we are going to talk about the characteristics of the quadratic function. So the very first thing is that I want everybody to remember that the quadratic function in a standard form is going to look like this. And of course, we are going to replace a, b, and c with some numbers. So please remember that this is how the standard form will look like. Also, you will see we'll be talking about the vertex form of the quadratic function. So ax minus h squared plus k. We will talk about this, we'll talk about h, we'll talk about k, we'll talk about what all those letters mean a little bit later. But please remember that's a vertex form. Please remember that because we are talking about the quadratic function, the highest exponent is 2. Okay, so you need to see a function that will have a power, the highest power equivalent to 2. Now, shape. As you see below, the two examples of the parabolas, the shape is, it looks like U. It can look like this, but it can also look like this, and in a second we'll decide when is our quadratic function going to look like this and when is it going to look like this. Graph of the quadratic function. It's called a parabola. It's a very interesting word. It's a parabola. So every time I say, oh, in this parabola, that means in this graph of the quadratic function. Now we have two graphs. We have two graphs underneath. And what we are asked to do is we are asked to explore the key features of the graph. And the key features that we are going to be analyzing are, first, x-intercepts. What I am going to do is I am going to make a nice straight line here, and I am going to be working with both functions. And I am going to write my answers for one on one side and for the other one on the other side. So let's see, x-intercept, that's where the function is going to go through our x-axis. Remember, this is your x-axis. So our x-intercept will have the coordinates of, well, this one is -4 and 0. And then the other one is 0, 0. We'll do the second example in a second. Now the next characteristic is the y-intercept. That is where our parabola is going to go through the y-axis, and that is 0, 0. I know, I'll move my paper up. Now, very often we are going to be talking about the vertex. And vertex is that point where the function is going to be changing from being increasing to decreasing, or like in this one, from being decreasing to increasing. So this is either this highest point of the function or the slowest point of the function. That is going to be our vertex. And let's see, what is the vertex of our first function? Again, we want to give the coordinate point. So the coordinate of this vertex is going to be -2, 4. Next thing that we are asked to say is we are asked to say where is the axis of symmetry. And the axis of symmetry, is that line that will go through the vertex. And if you imagine folding the parabola along this line, those two parts are going to overlap. So what happens is that this point is going to have a mirror reflection here, this point right here, and so on. So axis of symmetry, because it is a vertical line, is going to have an equation described as x is equal to -2. That's our axis of symmetry. And then the last thing that we are asked to describe is end behavior. We talked about you talked about end behavior of the function in Algebra 1, Volume 1 class. And the way we are going to write the end behavior is we want to think about what is happening with our function as x is going to positive infinity. So think about this. This is your positive infinity, and this is your negative infinity. So what is happening with the y value? So as x is getting larger and larger, your y value is going to get smaller and smaller. So this is what I am going to say. I am going to say as x goes to positive infinity, my function is going to negative infinity. And then the same thing, as x goes to negative infinity, the function is going to negative infinity as well. I'm going to move my paper so you can see the graph a little bit better, and I'm going to explain this one more time. When I say f of x is the same thing that y. So what I am trying to say is that as the x values are going to get larger and larger, so let's say I am at 1, my y value is at -5. When I am at 2, my y value, well, it would be somewhere here if I can predict that. 3, well, it's going to get even smaller and smaller. So as my x values are getting larger, my y values are going to be getting smaller and smaller. So therefore, I am saying that as x is going towards positive infinity, the function, the y values are going also towards negative infinity. And then as x goes to negative infinity, the function is going towards negative infinity. I think I said this backwards the first time. So one more time, as x goes to positive infinity, the function goes towards negative. And then as x goes to negative infinity, the function is going to negative infinity as well. With the quadratic, please remember that those two must be the same. So they are either, both ends are going to go the same direction. So they are either going to go towards negative infinity or positive infinity. Let's see how the second example is going to work for us. We are going to do the same thing. So x-intercepts, let's take a look. We know that this is our x-axis. We know that this is our y-axis. So the x-intercept is here, and then the second x-intercept is here. I'm going to list them as points. 1, 0, and 3, 0. Y-intercept, I'm looking at the y-intercept, so I'm looking at the y-axis. This is where the graph is crossing the y-axis, and the coordinate of this point is 0, 3. Vertex, remember that the vertex is that point where the graph of the parabola is changing from being either increasing to decreasing like in the first one, or from being decreasing to increasing. So this is the vertex, and the vertex has coordinates of 2 and -1. Axis of symmetry, remember that this is that vertical line that is going to go through the vertex, and because it is a vertical line, it is going to have an equation of x is equal to, and in this case it is equal to 2. And then the last thing that we need to find is our end behavior. So always it is a very good practice to write this down, set this up. As x goes to positive infinity, what is going to happen to your parabola? And as x goes to negative infinity, what is going to happen with f of x? So take a look at this one. As x goes to positive infinity, so when my x's are going to get bigger and bigger, my y values are going to get bigger and bigger as well. So I can say it's going towards positive infinity. And as x goes towards negative infinity, my y values are going to get bigger and bigger. So they are going to go to positive infinity. And look at this, how convenient. I did just tell you that they need to go in the same direction when we are talking about the quadratic function. So to summarize, couple important things to remember about the graphs of the quadratic function. You are always looking to have a U shape. You can have a smiley face, or you can have a sad face. The graph of quadratic function is called a parabola. You will see we'll often be looking for the x-intercept and the y-intercept. Vertex, it's a very important point on the parabola or part of a parabola. This is either the minimum value or the maximum value. Axis of symmetry, think of the vertical line that goes through the vertex, and think of that vertical line that you could fold your parabola, and the two parts of the parabola would overlap. And then think about the end behavior, and think about the end behavior that they have to go the same way. So as x goes to positive or negative infinity, in this case, our function, our y values are going to positive infinity and negative infinity for this function. All right, thanks for watching, and let me know if you have any question. Your assignment is going to be to complete this entire paper.